Hello, am I audible?
Yes, sir, you're audible, sir.
Okay, Devi ma'am, you're there?
Yes, Adarsh, I am here.
Okay, fine. Yeah, so good evening, everyone. Welcome to the session. So this is the first session for the penultimate session week of the course. Okay, so this is week 11, and so I hope you are doing well with your project. Some of you have been half through, some of you, just started. So best of luck for your project. And so this is a kind of session where we will be, some part of it will be based on discussing some of the questions or doubts regarding week 11 content. Okay, and so just wanted to know how many of you gone through the videos. So really sorry for the delay that has been caused in releasing this week's content. Okay, there was some operational issue, so got the content released a bit late than usual. So I'm not sure if you could have used that this weekend to watch the videos, but I'm just wanted to know how many of you started watching the videos. Okay, so yeah, so okay, I've got one raised hand, so I'll consider some of you have already started watching. Yeah, so this is where we generally come out of talking about more than HTML, right? So we came up with till now we have started work studied about HTML, CSS, and this is where we talk where what is beyond HTML. Is the web development confined to only this part, right? So these are some things that we will look in this week. Okay, we'll also introduce a bit of JavaScript. So the introduction of JavaScript has been done in week 8 itself, but this is more of a formal introduction where we come across some of the theoretical parts. Okay, what is it, what exactly it does, what is its role in web development, and why is it so popular as far as web development and adding dynamic nature to a web page is concerned. Okay, so yeah, so this is where you can discuss your doubts. Okay, in the latter part of the session we'll have our faculty in. Okay, so we'll be joining in a while. So we'll be discussing giving a light on the contents of week 5 to week 8. Okay, so a normal discussion on what all we have covered, so that you get a better idea. You can ask your theoretical doubts, conceptual doubts, just to give you a clear idea on what kind of testing will be done in the quiz 2. Okay, so so we'll first part of this session will take some certain doubts, okay, regarding week 11, and then when the professor joins in, we will go with discussion of or a revision, a quick revision, a flashback of weeks 5 to week 8. Okay, so yeah, any questions, please go ahead. You can unmute yourself and type the questions in chat also. If there are technical questions, keep it to them for now. Let the professor join in, and they can, and once we are once we gave you the overview, you can unmute or yourself, or you can add your comments on the chat. Okay, so that will be the case. Till then, till the professor joins in, we'll try to take some other doubts. Okay, probably regarding the content of week 11 and stuff. Okay, so yeah, please go ahead. Yeah, Rakesh, you can ask questions for mock too, but see, actually we'll be having a revision session, quick session on mock 2 paper discussion, right? Just as we had in I guess week 4 before quiz 1, right? So I'm not really sure it was week 4 or week 5, but yeah, we had a separate session, a dedicated session for week mock 2 discussion. But yes, you can ask a question. Yeah, please. Okay, so if this question requires a detailed understanding, I would ask you to wait. Otherwise, if a brief overview, I can give of the question.
Okay, sir. Okay. I was asking about the last question of mock 2.
Okay, is it descriptive?
Yes, sir. Yes, sir.
Okay, what about it?
The why put method is considered as idempotent, whereas post method is not in the context of the rest. So this concept I do not have.
Hmm.
So
See,
if it is
what is an idempotent method? What is an idempotent method? What happens is when you run a command, okay, on the database, what happens when we send or get or try to change the data of the database? What happens? Certain action happen in the database, and the data gets altered. Okay, now that can be done by both post and put. Okay, in case of post, what will happen once the data is there? Okay, and we have added the data in the database. We are adding a new data in the database with the help of post. Okay, so that will be added once. Okay, I've done simple logic, added a new data into database using post method. Okay, so that data got added once. Okay, but if I try to add the same data, exactly same parameters with using post, what will happen? The data will not be added. Okay, with that, what will happen if the data doesn't get added? It will not alter the state of database. It will not change the database. Okay, but when do we use? But what happens when we use a put method? Okay, in case of put method, generally we talk about updating. Okay, so when we update a data in the database, what will happen? Even if we are doing that with the same data, what will happen? The data gets replaced. Okay, the data gets replaced. Even though the data is same, the data gets replaced. Okay, certain parameters as
sir,
well. Yeah,
the data same means the primary key like that.
primary key will change, right? Primary key will change. Anyway, you're trying to see, put method is generally talking about update. Okay, so when you are trying to update a data, you will be retrieving first the original data in the database and try to change it. Okay, so in that case the primary key remains same. Okay, I'm talking about adding a new data using put method.
Okay.
Okay, so let's say, okay, let's consider about update. I was talking about update, so let's say we are taking a data which was already there in the database, and trying to update it with the put method. Okay, now if we try to run this more than once, okay, the data gets updated every time we run a put method. That does not happen with post.
Okay, so like which one is better? Like should I use post or put for updating?
For
So
updating, you
is
should
there
go
any?
with put.
Okay.
Okay, for updating, you should go with put. But same
Okay.
thing
Actually,
can be actually say what will happen when, so what is the condition here? If the data remains same. Okay, so if the data remains same, what will happen with the database using these methods is the question. Okay, when you will be using put, or when you are talking about update, the data will change. Okay, you would not want to play around with database. And let's say in the normal scenario, you every time you want to update, you will change the data. Okay, so if you're doing that, even post method is okay, no issues with that. Why? Because we are not talking about adding the same data to that particular place. Okay, we are changing the data.
yes.
Got it? So if the data is changing every time you want to update it, you can do it even with post, no issues.
Okay. So got it.
Okay, now this is idempotent. Idempotent means the you know the in the state of the database does not change. Right? What was the state? The data in the database does not change. What is safe is the state of connection. Okay, even if I'm trying to change the connection, this will happen with methods like get and post. Okay, so just to give you a clear idea, you can go through the http. Just give me this, wait a minute, I'll give you a link. You can go through the http methods of mdn docs. It will clearly give a clear differentiation between all the methods, right? Just give me a minute. Clear differentiation as in which method is idempotent, which method is not. why is it not, okay, which method is safe and which method is not. So you'll get a clear idea of what is the difference between a method being safe and idempotent. Just give me a minute.
Okay, sir.
Yeah, so I've sent a link. So this is where this is a simple, simple page which gives you the entire idea of what are all the HTTP methods. Okay, what is their condition? What is their characteristics? Like, are they idempotent or not, safe or not? Okay, so I would suggest each and everyone who has this confusion, just go to this thread or this link. You'll get a clear idea. Okay.
Thank you, sir.
All right. Yeah. So, okay. Any more questions?
Sir, while creating the project, I actually thought of creating a navbar in it. Using the nav tag, I was trying to get to it, and I discovered in the process that Bootstrap already has a predefined set as it for navbar.
Yeah.
And it includes the files. No, sorry, not files. It includes two different links for CSS and JavaScript. There are three JavaScript links that are to be put at the end of the body tag, and one is of CSS styling that is to be put at the starting of the head tag. So if I try to include the navbar from the Bootstrap website itself, do I need to understand how it works? Because in the project Viva, it could be asked how it might be working. Do I need to worry about that? Or
No Bootstrap will be asked in detail. Okay,
right.
so if you're implementing a styling and that is done with the help of Bootstrap, we'll not go into details of that. Okay, one thing. Secondly, for a certain part, see what happens when you import a link in or try to link Bootstrap link into your HTML file. Okay, and you do that for a navbar, it defines certain rules. Okay, for example, if you want to give a column space, okay, and give certain rows and columns, okay, and give a navbar, give some space, so it has its own definition which is defined by the classes and the IDs. Okay, so that you need to take care of. What are those classes? Okay, because if you simply call the link and do not have any classes there, it will not do the work.
All
right, so if you are creating, so if you can go through the screencast of Bootstrap, right, how it is actually implemented. Okay, so what is done there exactly, we have imported the link, that is imported the Bootstrap link in our style sheet. Okay, and then we have gone through, so that link is particular to all the things that can be employed. Okay, so there will be rows, columns, gutters, and forms, tables, stuff like that. So if you want to include a navbar, you have to go to the section which has navbar. Okay, and then you'll have to look at that part which has the coding of that particular navbar. It will show you a preview, and then the code that is there. Okay, so that code will have certain classes. Okay, that classes have to be embedded or embedded into your class inline. Okay, then it will exactly start showing.
Even if I didn't include the navbar styling inline, the navbar was still working. I just couldn't alter the styling, as in the text or the color or background. Anything that was all outside my control. They were
Yeah, that's what.
predefined. Yeah.
I would like to add to this. You can actually change the styling. You just need to like define the styling for that class, and you need to put exclamation mark important, and then that would be like given the priority. So that's how you can
Overriding.
change the styling.
You mean overriding the existing styling?
Yeah, exactly.
Yeah, so there may be something which is so what happens is if you are adding a styling in Bootstrap and also giving an inline style, the preference will be given to inline, right? So we have seen that in CSS precedents.
Yes.
What Pushpak is trying to suggest here is you want a particular thing and you know that this line of CSS does that. So you just give an important exclamation mark important there, and everything will be overridden by this thing.
All right.
Okay, so try that. You can use styling. We'll not ask you how did you come up with this design. No issues.
Excuse me, sir.
Yes.
Yes, sir.
So where should I place that exclamation mark?
Just beside that particular style. Okay, so see, for example, I have a div tag. Okay, and then how do I target a div tag in CSS? I'll write the div and then give curly bracket and write all the stylings. Okay, so let's say this div tag has width of 100 pixel. Okay, and color, background color, and some border. Okay, so these are the three attributes that we have defined for that particular style. Okay, but for some reason, my border radius or border is not getting shown. So this may be because it has been overridden by something else. Okay, now you want this to show anyhow. So just write exclamation mark important beside that border attribute. Yeah, so you can refer to this given by Pushpak, right, in the chat. Right, so it is simple. So we are targeting an ID, okay, with the hash, and then there is curly bracket, and then there is one attribute that is background color. It is black, which I want it to show no matter what styling I'm using later. Okay, what you need to do is just give exclamation important right after that. Okay. Yeah, so you just, if you want to get an idea of this, I guess there was a question and quiz.
Yeah, in quiz one there was a question.
Yeah, so there was a question and quiz with the same concept. Okay. Yeah, so there is one question from Sachin. Can we use raw SQL queries in the project at some places instead of Flask SQL? Yeah, surely, no issues.
Hello, sir.
Yes, sir.
I have a question regarding the XML. Actually, previously I have used the vector graphics tools, but I didn't know that it is actually just a HTML like code. So throughout the lectures, it is like told, or there may be some question that there is no like tags like defined for XML. So I am interested to know that how these things are rendered. Like suppose and like different companies can create their own tag. So in XML, how these things are like a computer know that I should put a circle or I should put a like this color.
No, so the tags are not defined, but the attributes are. Okay, so if you want to create a tag, you have to define the attributes, what it takes and how it shows. Okay, so that's why we might have one of the questions related to custom tags. So these are the tags which are created by us. Okay, so we define, it's just like it is analogous to a function in Python, right? So we create a function and we define what this function does. Okay, simply giving the name addition or add will not add two numbers. Okay, we will also have to write a logic that will add the two numbers. So similarly in tags also, what we do, we'll define the tag name. So tag names are, for example, if I want to add an image or create a tag that simply adds image in certain dimensions. Okay, so since I'm adding image, it would be intuitive to name that tag as image. Okay, otherwise you can name anything, right? So
Okay,
that
okay,
is the
sir.
idea.
Got it. And got it. But one more thing that actually I I have drawn a circle and a square,
Hmm.
and rendered the same file using browser and using the software. The styling is different. So why these things happen? Like suppose I put a letter R, the styling or font of the R in browser is different from the when I open it with the actual software.
Yeah,
So
so there is a predefined styling that is provided by the browser itself. Okay, there is predefined styling. So just give me a minute, I'll show you. Let's say, or let's say I'll share the screen and I'll go to a new page. Okay, so this is a very dynamic page, right? So it will have a lot of stuff. But if I have an image, not the image, if I have a simple HTML file that shows nothing, that has only simple HTML, just give me a minute, I'll try to find one. Yeah, so can you see this page?
yes, sir.
Right, so this is a previous page, right? So this we have taken in the previous session, right? Creating this page and all. So here I have not defined any style for this page, but if you see here, user agent style sheet. Okay, so it has this predefined styling. Okay, which is
Okay,
provided
okay.
by the browser.
Yes. Okay,
Okay, so
got it.
that is the style. Even if I have not given any style, I have not linked any style sheet. This user agent style sheet will give additional, not the additional, the default style to the text that we are creating in HTML. Okay, which is not done using CLI or source or other softwares. Okay, so in that case, you will see different types of styling for different things. With this one is more standard. That's why most of the browsers will see same thing. In most of the browsers, the HTML files are rendered, and we see they are similar.
Yes, sir. Okay, got it.
Yeah, so that is the thing.
Excuse me, sir.
Yes, sorry.
For plotting graph, can I use chart.js?
Okay, so you want to add JavaScript, is it?
Yes, sir.
Okay, is there any issue with Google and the extension provided by Google or Matplotlib?
I
I
don't
think
know
there is
how
a
to.
extension, Google Plots, I guess. I'm not sure with the name.
But I don't know how to incorporate Matplotlib. Sorry, in HTML, how to render it.
Okay, see, you don't have to render Matplotlib. See, what happens is with the data, anytime you are adding certain things in the database, you are dealing with the data. Okay, using that data, you can plot Matplotlib. a plot in Matplotlib. Okay, that part is simple. Now, after this, once the plot is plotted, there are two things that we need to do. What will happen when you, run that Python code which shows the plot? Okay, it will run and show you the plot in the front end on your screen. Okay, that you do not want. What you want is the plot should not be shown on the front end, but an image should get saved in the database. Okay, saving an image in the database is a one-line code. Okay, plt.savefig. But not showing the plot on the screen is something that requires backend extension. Okay, so there are there are threads on Discourse which talks about AGG and TKAGG. Okay, you can go to those threads and embed your plot, not embed, we can call it, simply not show it. Okay, and just save the figures. Okay, now once the figure or image is saved in the database, not in the database, in our file structure, in our folder structure, particularly in the static folder, if it is saved there, you can simply call it like an image tag. Just give the destination. Okay, embedding JavaScript just for images looks a bit code heavy. See, if you're using JavaScript for a lot more part of your application, then adding image through JavaScript would be okay, fine, right? But only for image, completely shift to a new language, will that be okay for you? Right, and for that you should be completely not completely okay, you should be considerably familiar with the language JavaScript.
Okay, sir. Sir, what was that? What was the name of that function? plt.show, and then
Savefig. You go through the Matplotlib document and just search for a saving figure, or don't have to go to documentation also. Just search on, just have a Google search on how to save figures in Matplotlib. You'll get that thing, right?
And sir, what was the name of that library for plotting graph? Google graph.
Google,
Yes.
Google Chart it was.
Google Charts, is it? Yeah. Okay.
Google chart. Okay, sir.
Yeah. So that will also come in handy. Yeah. So a reference is also given by Pushpak, right? So Pushpak, thank you very much for your timely references. Okay. So this is like what is happening here? We are importing Matplotlib. Okay. First thing. Second thing is that backend which I'm talking about. Okay. So you need to change the backend because you don't want the figure to appear on the screen. And the third thing is saving the figure. Okay. And the space is actually dot. Okay. plt dot savefig.
Yeah, I accidentally missed it.
Yeah, sure. Got it. No issues. Okay, so you can save this, take the screenshot or save this message somewhere. We'll get the idea. Sorry. Okay, yeah. So this was good question, Saurabh. I guess we are emphasizing on Matplotlib a lot. That's why we are talking about this. But you can have other things which do not involve JavaScript, right? So I hope the explanation given by me regarding why not JavaScript is acceptable. Okay, and you will be doing a lot more JavaScript in next part of Mat application development, right? So let's have some patience for that. A lot of JavaScript in the next part.
Hello, sir. What is the parser? Like in SGML, it has own parser, but XML and HTML2 for these things uses the SGML parser. but HTML5 has its own parser. So what is the parser thing?
Parser, see, I cannot give you the exact definition, okay, but what I reckon with parser is, so it is like the element, right? So if you are creating an element, so okay, not creating an element, let's say certain elements are defined in HTML, okay, these elements are also defined in SGML, okay, and while talking about SGML, we also have read that, okay, this is something which is syntax not relaxing, right? It is not syntax flexible. It wants syntax as it is mentioned. In HTML5, it is not like that. Okay, even if you miss some certain syntax, things might not come up or might render completely. Okay, it will not show any error. Okay, so what happens? So we are defining certain tags. Okay, a lot of tags are defined which more support like videos and canvases and stuff. Okay, so these are the tags defined in the HTML5. Okay, now when we are creating a HTML file, we want these tags to be understood by the compiler or the browser. Okay, how is it made easy for the browser to read? Okay, what we need to do, that is by the parser. What is parsing, by the way? Understanding a code. Okay, retrieving useful information or retrieving interpretation of a code. Okay, so HTML code you have written, okay, you are defining the doc type HTML5. This means that the browser should use the parser of HTML5 to understand what is written as a code.
Okay, so it is like similar to the compiler, is it?
Yeah, correct.
Okay.
Okay, only that it does not look after manipulations and heavy stuff. Okay, only rendering.
Yes.
Hello everyone, Nitin here. Adarsh.
Yeah, hi sir.
Yeah, hi.
Welcome to the session.
Thanks. Yeah, I wasn't sure if my audio was working. There was some small problem with it before, but yeah, anyway. So yeah, sorry for coming in a little late, but yes, I think either we can, if there are any questions, we can straight away go to questions, or if I think you had some just sort of a overview, right, to present about what has been covered so far.
Yes, sir. So I guess we can go through the overview in a brief, and then questions can be asked.
Okay, yeah. I think I can just put that up so there's a point of reference. So anyway, good evening, everyone. Yeah, Adarsh, if you can share that, that would be great. I mean, can you do that?
Yeah, sir. I'll share.
Yeah. Thanks. So meanwhile, yeah, hello everyone, and sorry for joining a little late, but it's basically an open session for any questions. We are at week 8, right? Pretty much 2/3 of the way through the course, and now you also have a definition of the project and so on. So please feel free, use this time to ask questions about the course, right? Anything that you find unclear, etc. Things that need to be maybe reviewed or anything like that. Yeah. So like the slides say, this is basically a summary of what we did in week 5 to week 8, right? We'll go on to the next slide. Yeah, so of course, the first 4 weeks were background, right? I mean, we started off with the basics of the web. What do we mean when we say web, and why we felt that the web was a good platform for application development, right? If you think about it, I mean, what's the title of this course? It just says modern application development. It doesn't actually say modern web application development. That was sort of implicit, but part of the reason why we are focused on the web is because it's a very sort of generic and broad platform for developing applications that are sort of usable on across a wide variety of different platforms and devices. Okay, so that is why we sort of focused on the web, which automatically meant that we would then be using the technologies of the web, HTML, CSS, and of course some JavaScript, but that's not really covered in this course, right? Those are sort of what we call the, I guess, the display technologies of the web, right? And there is also the underlying HTTP protocol, which is actually used for transferring data. But all that is only background, right? Because the rest of the things, if you look at it, right, this whole idea of the presentation layer, which is the view, then the models, controllers, and so on, most of it, we have tried to look at it at a level which is not even restricted to what is capable, what is possible on the web, right? Because those are sort of more generic concepts, right? Of course, as far as concrete examples are concerned, we have definitely focused on the web itself, right? So the presentation layer, the view focused on HTML and CSS. Models were about how we can implement databases, or rather use databases in order to implement models of the data that we want to process inside our application. Okay, so those were the first 4 weeks. Then after that, so what we are reviewing now is week 5 was about the controller, right? So just a sort of natural conclusion of MVC, right? The model view controller, right? So MVC, as we sort of mentioned, was broadly something that you can look at as a design pattern, right? And I'm using the word design pattern in a somewhat broad sense. There is a reasonably well-established set of definitions of what design patterns are, right? And if you look around and read more about this on the net, then you'll probably find that people sometimes say that MVC is not exactly a design pattern. It is in fact a combination of multiple design patterns and so on. Okay. Beyond the point, I'm not going to sort of split hairs over there. The main reason why we find MVC useful is because it's a good way of thinking about how to design an application. Right? And as part of MVC, the controller, right, is the part that actually implements the logic, meaning that it implements the functionality that you want. Okay. And the fact that the web applications are built around ideas of requests and responses means that controllers are the ones that essentially decide what kind of response to send for a given request. Okay, so in some sense, the controller is the middleman between the view and the model. Okay, it takes inputs from the view, passes because the view is what is seen by the user, which means that the controller is actually taking inputs from the user and using that in order to make queries or send messages to the model, which is the database. Okay. And once the model, sometimes the model needs to be updated, meaning that you are actually making changes to the model, or sometimes it just needs to give you data, give you information. Okay. That is a sort of read or a list kind of request. Either way, the controller is sort of passing that message on to the model. The model sends back some information, and depending on that, the controller then invokes an appropriate view. Okay, so that's sort of where the controller sits in the whole process of doing the MVC design pattern. Right? And one of the most common sort of approaches, or rather one of the most common controller patterns, again, right, is something called CRUD, the create, read, update, delete set of operations, right? Because any set of models, any database model that you are looking at, ultimately what we are trying to do is we want to be able to create an instance of a particular type of data, or we want to read, either fetch information about one particular instance of a model, or about what are the number of different types of models, or the number of instances of a particular model, right? So that's the read part. Then you could have update, where you want to go and modify something. Or of course, there is delete, which is an extreme form of update, where you basically remove one entity completely. And then effectively, so delete is the opposite of create. Okay. So this CRUD is, well, it's just a nice acronym, right? It helps us to understand the common types of operations that are performed on models, and therefore what needs to be done inside a database. But the fact of the matter is that's not, controllers are not limited to CRUD, right? A controller could be pretty much any kind of functionality where a view needs to trigger some activity, right? And usually results in some updating of the model, and then an appropriate view being called, displayed in return, in response to the controller action. Okay. So the controller is all about actions, about doing something, right? Which is why we say, okay, it's a business logic. Okay. And in terms of Flask, ultimately what happens is that the root, decorator, right? So the @app.root decorator that we use right? So what is a decorator? All that it's doing is it's sort of adding extra functionality on top of a given function. So it takes a function as input and returns another function as output. Okay. So basically what it does is it takes a function and says, okay, I'm adding something extra on top of it. Right? So if I just define a function saying index and I add a root decorator on top of it saying that slash is to be routed to this particular function, the result is a new function which will get called whenever the Flask, the runtime gets a request meant for the root slash. Okay, so the roots and how they are related to the controller is something slightly specific to Flask, because that is partly Python syntax and the way that it is used in order to implement certain things. But this concept of roots and attaching them to controllers is something that is common. Right? Whether it is Flask, whether it is Django, whether it is Node.js, one of the platforms or frameworks that you have over there, right? Or many other, pretty much any other reasonably modern and complex framework for building web applications will have this notion of roots and how you should take roots and direct them to appropriate functions. Okay, so week 5 was basically about that, right? How you could sort of look at how you should look at the idea of a controller and how it can be implemented in practice. In week 6, we sort of generalized the idea of controllers and said, okay, look, at some point, if we abstract away the complete front end, right? That is to say, what is it that the person gets to see? And you also abstract away the back end. In other words, how is the data stored? What kind of database is being used? Is it MySQL, or is it Oracle, or is it SQLite, or even some other kind of database, right? What is left once I remove that part, right? I remove the exact details of how the model is stored, and I also remove the exact details of how the view is displayed. What remains is some kind of a programming interface that allows us to communicate by means of calling sort of functions, right? With and those functions are basically allowed to modify, rather are allowed to either retrieve data or are allowed to modify parts of the model. Okay, so a programming interface can be thought of as just a set of functions, right? And an application programming interface or an API can be thought of as a library of function calls. Okay, it just says, okay, if I call this particular function with these parameters, then this is what will happen. Okay, so at its most basic level, that's what an API is. Now, we of course want to go one step further than that. We want to have an API that can be called using the web technologies, meaning that it is now called using HTTP connections, right? So I actually make an HTTP connection and send some requests, and the response, that is the output of the function, is passed back as the response body of the HTTP transaction. Okay, so bottom line is, the first thing to do, think of APIs as just function calls, okay, a set of functions, so a library of functions. And in our case, it's an HTTP API, meaning that instead of having something which is directly in a Python module, right, which you would just import, or a C module or a C library, which you would use some hash include and some -L in order to compile the libraries in. This is something which is based around the HTTP protocol, which means that anybody who can speak that HTTP protocol language can communicate with this API. Okay, so that's the first thing about an API. The second thing we did was REST. Okay, and REST is a very common term and is worth sort of thinking about and understanding. It is also one of the most misunderstood and miscommunicated concepts that you will find nowadays with regard to any kind of web application or anything related to that. Okay, and I am not guaranteeing that I have done a 100% perfect job of actually communicating exactly what REST architecture is, because at the end of the day, there are a lot of conflicting pieces of information over there, right? The best source of information, if you really want to understand what REST is probably to read the PhD thesis of Roy Fielding. Having said that, I wouldn't really recommend that beyond a point, because that is also a very technical document that talks about some specific requirements of the web as it was in early 2000s, in the early 2000s, and why they led to this particular architectural style. Okay. What is important from our point of view is that REST is part of this whole notion of a clean separation of concerns, right? It allows us to design APIs in a neat way so that the model, we don't care about how the model is implemented. We don't care what the views look like. And the REST API is sort of just follows some reasonably standard kind of practices and conventions in order to achieve certain kinds of functionality, right? Specifically, there are certain ideas in REST, such as the fact that because your client and your server are separated from each other, right? You do not want to sort of maintain client state at the server. That is to say, the server should not assume that the client is in a particular state at a particular point in time. Okay. And that is in some sense, the most crucial idea of REST. Okay. To explain that a little bit better, see, take an example of even this browser that you are using currently on your laptop or your phone or whatever it is, or some app that you are using, right, in order to connect to this call. Okay. Now, your laptop or your phone knows that at this point in time, you are watching this on the screen. Okay. Which means that if you ever touch part of the screen or if you press a button, it knows that the button is, or the touch on the screen is meant for this particular application, right? And it automatically sends it to this application to process it, right? In other words, that is what we mean by state. The server, which is whatever is running on your laptop, right? The thing which is actually displaying something on the screen knows exactly what is being displayed on the screen and what you are looking at. And if you move the mouse, then it knows that the mouse is over one particular part of the screen, right? And if it is some link, then it should sort of make it hover or do something else. Or if you click over there, it should respond in a certain way. In other words, the server knows exactly the state of the screen and it knows how it should respond if you click in a certain place. But when you do the same kind of thing and develop an application over the web, right, over HTTP, the server in general does not even know whether the client is looking at this page right now. All that they know is what was the last request that they got from the client and what was the response that they gave. Is the client still on that same page? Did they close that tab? Did the power supply fail over there and their computer has shut down? Did the network link get cut? The server does not know any of that. Okay. Therefore, it cannot sort of assume anything about the state of the client, which is why the client has to effectively transfer some notion of what is its present state to the server every time it is sending a request. That is precisely what representational state transfer refers to. Okay. So this whole idea of REST API is an architecture, right? It's not one specific, it does not mean CRUD. Okay, so that's one common misconception that you need to be very clear about. REST by itself does not mean CRUD. CRUD is one form of an implementation of some of the parts of a REST API, but REST refers to something a bit more generic than that. Okay, and the whole point is, why is it important? Because it very nicely mirrors the concepts that are in use in implementing something on the web. Okay, and therefore, we spent some time basically understanding what REST APIs are all about. And as part of this, you also need to understand a little bit about OpenAPI, because that is something which is commonly used in order to document and, in fact, even construct APIs to some extent. Right? OpenAPI allows you to sort of focus on how you can systematically create a structured document, right? A YML file, which can be used for multiple purposes. One is to actually generate documentation about the API. The second is to generate sort of basic code, which can be used in order to implement the API, right? So this kind of a standardized specification makes it easy to communicate the ideas of an API across different people. Okay, so that was essentially what week 6 was about. There is a question, so yes, go ahead, Pushpak.
Sir, you said that this whole thing, it does not store the state, which is completely fine. I understand that. But then if we, let's say, talk about Facebook, we are scrolling through the website. We can see the active now status of the user. So is that storing the state?
So, okay, see, there are two parts of state over there, right? One is Facebook does need to have some concept of state corresponding to a user. So in fact, I mean, even something as simple as logging into Facebook, right, means that there is some state over there, means that the server knows that you are currently logged in. Okay. The problem is the server only knows that you logged in at, let's say, 5:25 p.m. Okay. At 5:25 and 01 seconds, it actually does not have any way of verifying that you are logged in or that you are even on the Facebook site. It just assumes that you are. Okay. So when Facebook says that so-and-so is online, pretty much all that they are saying is the last time I checked, they were online. And maybe that last time was hopefully only a few seconds ago, which means that it is reasonably up-to-date information.
So is it so like it's constantly checking back with the client that the user
They
is
make correct. They make certain assumptions, right? So Facebook makes an assumption that if you have logged into Facebook, you are going to be there at least for the next so many seconds. And therefore it considers that anybody who was here within the last so many seconds is currently online, right? Not just Facebook. I mean, there are lots of apps where they actually sort of say that, oh, so number of online users are like whatever, some 150 or something like that, right? Or they'll say that, in fact, you go to Amazon and you say 35 people are looking at this product right now or something like that. Same thing. It's not that literally those people have their faces turned towards the screen, right? They clicked on that link at some point within the last so many seconds, and therefore it assumes that they are still on that page. Beyond that, the server actually does not know, because until it gets the next request from the client, it does not even know whether they have closed the browser or shut down their machine.
all right, thank you.
Sure. Okay, so yeah, week 6 was basically about APIs, right? So like I said, this is a reasonably important concept. The idea of REST is an important concept to understand, right? And why is it so important? Because it helps you to sort of design your apps keeping the constraints of the web in mind. Okay. And if you look at Roy Fielding's dissertation, that's pretty much exactly what it is all about, right? It is trying to sort of design an architecture for software which is well suited to the constraints imposed by the web, by the HTTP protocol and whatever are similar things like that. Having said that, the actual REST is not limited to the HTTP protocol, right? It just talks about generic sort of client server kind of protocols. REST could in principle have even been implemented with other protocols. Okay, so keep all of those in mind and don't assume that REST is just something that, okay, it is CRUD. Basically, it is as long as you've implemented CRUD, then it is REST. Maybe it is. It's not really making full use of REST. On the other hand, you could also ask, do I really need to know what REST is? Possibly you don't. You can still build an app without having to worry about it as long as you follow other generic principles. But the moment you want to go a little bit beyond just the basics of what CRUD and other things can do for you, you probably need to spend some time understanding why REST is useful. Okay. All right. So that was week 6. So let's move on. Next slide. Yeah. So after that, so essentially with week 6, we had sort of most of the core ideas that are required in order to build an app are there, which meant that from week 7, we started actually diving a little bit deeper into certain details of specific parts of an application, right? So week 7 was talking about the backend system, right? And when I say backend system, I'm talking about everything that is required in order to store data, right? And there were some parts of this, such as the memory hierarchy, computer organization, and so on, which are important in order to understand why things are built the way they are. Okay, because what you need to understand is, if I had some kind of a magical storage system where anytime I make a request to it, it will immediately be able to give me the response. When I say immediately, literally immediately, right? With like zero delay, right? If it, or at least a very small finite delay, which is constant, irrespective of what I am searching for, right? That is the important part. If the delay in sort of retrieving information is constant, independent of what I am trying to do, then you don't need all this memory hierarchy, different kinds of storage elements, different, even databases. You don't need databases. Okay? But the fact of the matter is that the way that data is stored, there are different types of physical storage systems, right? So hard disks, for example, magnetic disk has typically high latency, but can store huge amounts of data. SSD has much lower latencies, can store large amounts of data, but not quite at the level of magnetic disk. There are DRAM, there is DRAM, which is used in pretty much any laptop or a phone or anything like that for the large amounts of storage of data, right? The gigabytes, when you say your laptop has 8 GB of RAM, the GB is DRAM, dynamic RAM, right? But then there is also some kind of storage which is very close to the processor, which is what we call the cache memory, right? Which is much smaller. That's like on the order of megabytes at best, right? But it's very fast, much faster than DRAM. And of course, you have the registers that are even faster and are right inside the processor, but are literally only like maybe tens of them. Okay, so this is why you need to have different forms of database structures, right? Because of the fact that I can't just make a query for anything and have it answered in constant time. I need to have proper data structures that are used in order to store information in a database, right? Various kinds of the tree is probably the most basic one, but much more complex structures are used inside databases, right? And in turn, they are used in order to construct fairly complicated search techniques that can be used in order to answer any query that you have. Okay? So the bottom line is, depending on the amount of data that you want to store, the kind of queries that you have, the kind of data that you want to store, right? You need to make an informed choice about what kind of backend to use, right? So SQL, meaning that when I say SQL, what I actually mean is RDBMS, right? Relational Database Management Systems. Those are very solid, very popular database systems that have stood the test of time, so to say, right? And have been around for quite a long while and are known to be able to handle large amounts of data and very efficient querying, provided that the queries are structured in a certain way. Now, one of the things that people found while trying to build more modern web applications is that some of the constraints which are normally placed on these kind of RDBMS may not always be necessary, right? And by relaxing some constraint, you can actually get far better performance, potentially at the risk of getting some answers wrong, or at least inconsistent. Okay, meaning that maybe if I, depending on the speed at which I make some queries or the order in which I make some queries, I might get different answers. But eventually, after some time, when I look at the database, everything should have the correct results. Okay, so that led to this so-called NoSQL, right? Which actually speaking is not NoSQL. It is more like not only SQL. It can support SQL type of queries, but also something beyond that, right? And all of these were sort of searching for ways by which you can scale to larger and larger kind of applications. And essentially the kind of large scale, internet scale applications that we are talking about today. Okay, so that was week 7, basically talking about the choices and what you need to understand about choosing things in a backend system. Week 8 was talking about the application front end. And actually speaking, this is something that is covered a lot more in application development too, right? In the second course, right? In week 8, pretty much all that I spoke about was this idea of asynchronous update of the front end, right? The basic concept of a DOM, the document object model. So this document object model is something that was brought in quite a while back in order for us to understand how to think about what a web page is, right? We call it a web page. That sort of automatically tells us that it makes sense to think of it as a document. And that document has text on it. The text is styled in certain ways, meaning that it might have some headings, it might have some paragraphs, it might have some sections, it might have bulleted lists, right? All of that is part of the document object model. And the thing is, at some point, people realize that by allowing this document object model to be dynamically manipulated, I could come up with very interesting behavior and changes that could result in a very nice sort of user experience. Okay, so week 8 was basically talking about the DOM, the application front end, right? And what we can do in terms of client-side computations and so on. It's more sort of descriptive in the sense that there are a number of different options that we have over here. There is a very brief sort of introduction to JavaScript, but like I said, a lot more of this would happen in MAD 2 and not so much in this MAD 1 course. So that's basically where we are at this point, right? I mean, at least as far as this review is concerned. So it's now open to questions. Anything that you have, anything which is unclear, anything that you feel needs to be discussed in more detail, please feel free to bring it up. And yeah, I'm here to take questions.
Hello, sir.
Yes.
Can I ask a question?
Yes. One general suggestion for everyone, please raise your hand. Even even if you want to type something in the chat, just raise your hand and then type it in the chat so that we can ask you in the appropriate order, right? But yeah, right now no one else has their hand raised. So yes, please go ahead, Rakesh.
Okay, sir, can you explain the routing part? Like we use slash for the main route,
Yeah.
and suppose there are slash students, then what is the difference between putting the URL as slash student or slash student slash? So that thing, can you explain that?
See, actually speaking, that is just a question of how the path. So that path, right, the slash student is what is usually called the query path, okay, in the HTTP URL. And strictly speaking, slash student or slash student slash, how you interpret it is completely up to what you are creating as the web server. Okay. Now, for background, what was originally designed for the web, right, for the HTTP protocol, the idea was that if I give slash student or then actually what the web server is going to do is it is going to go and look for a file that is present somewhere in your physical server, right, which has the name student. Okay. Whereas if you give slash student slash, then what it will do is it will go and look for a directory called slash student. And inside that directory, it will look for an index. What is that index? Usually the convention is that the index should be called index.html, right? But whether it is actually index.html or whether it is something else is actually a convention. What I mean by that is there is nothing about the HTTP protocol that says it should be done this way or that way. If you go and if you ever try setting up an Apache web server, you will find that there is something in the server that says the default index to try is something called index.html. Okay. So when web servers were built with the idea that you are essentially serving static files, right? Looking for HTML files or looking for any kind of file and sending that, then this slash student and slash student slash would have meant something very specific. Slash student would have meant look for a file with the name student. Slash student slash would have meant look for a directory with the name student, and inside that look for an index file and send it. Okay. But now what are we doing with Flask and routing? We are just taking slash student and essentially telling Flask that whatever this string matches, this is called this function. So at that point, it is up to you, right? If you put a slash at the end of it, Flask will still, it will explicitly look for that slash. It will require the slash to be present at the end of it in order to match that particular path. Only then it will call this function, right? There is nothing sacred about it as such. It is entirely up to you. You can choose to put the slash or not put the slash. Having said that, putting a slash where unnecessary or not putting a slash where it is usually necessary is only confusing. It doesn't help anybody, especially if somebody else has to understand your code.
Okay, sir, got it. Thank you.
Sure. Yeah. Are there any other questions? By the way, I mean, no, feel free to ask questions on any aspect of the course. It need not be restricted only to these 4 weeks that we have looked at. at this point, I hope everyone has also been working on the project and so on. So if you have any other questions, then feel free to ask. Okay, interestingly, there's like no particular questions, in which case, is there any other feedback?
So there was one question regarding what is an HTML parser. So
yeah, see, parsers in general, parsers are used for, I mean, a parser is what a computer uses in order to understand or to interpret anything that is written in a structured language, right? So if I have written, I mean, if I just open a editor like Notepad or WordPad and just type in some text, then there is actually no parsing involved over there, right? It is just text which some other human being will read later. But supposing I am creating a .c file, right? A C file which needs to be compiled, then that C file has to have a very specific structure, right? It will probably start with some hash include. It will then have some int main as the main function. And then afterwards, there will be some open curly brackets, close curly brackets, and so on. Similarly, if it's a Python program, then it will probably start with some statements that say import something. After that, there will be some def and function definitions. There might be some class definitions. And inside the class definitions, there might be function definitions, right? So that structure is required. Otherwise, if I just write anything without really caring about what it means, then beyond a point, the structure of a program becomes meaningless, right? It doesn't convey what you are trying to do. So what does a computer do when it is presented with such a program? It has to first break that program up into small parts, right? And try and understand whether those parts are actually following some grammar, some structure that is expected for the program. So if it's a Python program, it has to start with some import statements, or at least even if it starts straight away with a function definition, that line should end with a colon. Then after that, there should be something else and so on, right? There should be some indentation and so on. So the parser is that very first step, the one that takes your input file and breaks it up into those components and actually starts begins to understand what that file is doing. Now, in the case of HTML, similarly, an HTML document must have a structure. It must start with a HTML tag and end with a /HTML tag, right? Before that, it is actually supposed to have a doc type tag right at the top, okay? And inside the HTML/HTML, there is supposed to be a head/head and then a body/body. Inside the head, it can have a title/title, right? So there is supposed to be a very specific structure in terms of how these different things are put together, what should come before, what should come after. If a tag is opened, then can some other tags be there inside it before it is closed? All of that information is specified as part of the HTML standard. So an HTML parser's job is just to sort of go through and break it up and say, okay, look, this is what has been written in the file. This is what I assume it means, that this is the header, this is the title, this is section 1 heading, this is a paragraph, right? It creates the DOM, it creates the document object model by parsing. In other words, by reading the file character by character, okay, or word by word. It literally reads it word by word. It defines a word as anything which is separated by either spaces or maybe some kind of non-alphabetical characters. It tokenizes, right? It basically reads one word at a time. And in the process, it constructs some kind of an internal model of the document, which is the DOM. Okay, so that is the job of an HTML parser. Now, HTML parsers in particular are designed to be very forgiving. And what I mean by forgiving is that even if there are a lot of errors, it usually tries to make a best effort to display something nicely, right? In other words, it says that even if there are errors in what is being presented, or rather what has been given, try and understand what the user might have meant, right? And do that. Now, programming languages usually don't try things of that sort. If you write a C program and you miss one semicolon in one place, immediately the compiler will bomb out and say syntax error, right? Similarly, if you have a Python program and you have not done the indentation properly, or if you have missed a colon after the function definition, it will immediately give you a syntax error and stop right there. Okay. The HTML parsers, on the other hand, generally don't. If you miss closing a /HTML, or if you have one inside the body, you start an H1, but you don't have a /H1, right? All of those, it will try and assume, okay, maybe this is what the person meant. After all, when they have started a different paragraph over here, they must have meant to close the header before that. And therefore, it will try and create what it thinks you meant, right? Which is very rare. I mean, most programming language parsers are not meant to be forgiving. They don't, because for the simple reason that in a programming language, you don't want the computer to try and be too smart, right? You want it to sort of do what you are asking it to do and not sort of guess what you want it to do. Okay. So yeah, that's basically the idea of a parser. An HTML parser is like a parser for any other language. It essentially breaks up your input text into tokens and then sees what to do with them. Okay. Yeah, there's a question from Snehal Nair. Snehal Nair, you're on mute, so I can't.
Sir, I guess he has posted his question on the chat because he's not able to unmute.
Okay. Yeah. All right. So the question is, I understand a decorator in general, at least in the context in which we have been using them, but the context seems muddy to understand when applied to multiple functions. Why don't simple function calls work with decorators? I am not sure I understand the question exactly. See, a decorator is essentially a function, and the simplest way to think about a decorator is you want to write some function, and then you want to sort of wrap that function in some additional functionality, in some idea, give it some extra behaviors. Okay, so one possible way of thinking about this might be, let's say you are trying to debug, right? And you want to have something where any time that some, let's say you have a Python program with 100 different functions in it, and certain functions you want to sort of have some debugging capabilities. In other words, whenever that function is called, you want something which will print out a message as soon as just before starting the function, and print out another message just after ending the function. Maybe it sort of measures the time taken for that function. Okay. So what do you do? One way of doing it is you go and you modify every single function that you want to capture in this way, right? For every function, you go and add one line in the beginning of the function saying, print out the current time, and at the end of the function saying print out the current time, and okay, it does the job for you. The problem is you might break some indentation, some functions might be too long, and finally, if you want to sort of remove this behavior, it becomes like really complicated to make sure that you have done it correctly in all the places. Okay. Instead of that, you can define a decorator, which essentially takes this function that you have created as input and gives you back another function, but which now has some extra behavior added to it. How does it do that? What the decorator does is, it first, the decorator basically gives you back a new function. What does this new function do? It first does some task of its own, right? Maybe it prints out the message or prints out the current time. Then it calls the function that you had passed to it in the first place. And after calling that function, it can then, if necessary, print out the ending time. Okay, or like just measure the ending time. Okay, so that's all that a decorator is. It takes in a function and gives you back a new function. And usually what happens is, in that new function, the function that you wanted to decorate will be there somewhere inside and will be called somewhere inside. It need not be, right? So the interesting thing about a decorator is, I could create a decorator that basically kills off a function also and does nothing. right? So I could create a decorator, which is a sort of a null decorator, which basically says that if I decorate a function with this, then this function will actually, even if I call it, it will never do anything. Okay. But the bottom line is, after doing this decoration, what has happened is that you now have something where it is a new, it has, what it has returned to you is a new function, right? And that can then be called. Okay. You can, so whatever you have got back, as long as you understand that it is a function, you can call it. So I'm not sure what exactly you mean by simple function calls don't work with decorators. You cannot, for example, in other words, if you directly call the decorator, right, all that it is doing is it is expecting a function as input and it's going to return a function to you. But you can then call the output of that, because after all, that in itself is a function that can be called. Okay, so it is possible to call the output of a decorator. You again have to put that parenthesis to say that you are now calling the function which is the output of the decorator and not just the decorator itself. A decorator has to be followed by a function definition, as in calling home function after the app root decorator won't work. So what happens is when you put the app.root decorator on the home function, it has changed the behavior of the home function. So what you have now got as a result is something where you cannot directly call home. It does, or rather, it does not expect to be called directly. It expects to be called from the Flask runtime in response to a particular URL query. That is the main problem that is happening, right? The moment you decorate a function, that what comes out as a result is something that is expecting a different kind of behavior. It is not expecting to be called as a regular function. But that is because of the app.root decorator, right? It is a very specific kind of decorator in Flask that does this. I could have a decorator that does something else. That all that it does is it prints a message before calling the function. Okay, and that whatever comes out as a result of that can still be called. So I won't have a problem with that. Right? Okay, yeah. All right. Next, Pushpak.
Yeah. So basically, I was concerned about the difference between Flask and Django. Flask is considered to be web server gateway interface, and Django is full stack framework. So what is the difference between these two terms that I just mentioned? I don't understand that.
I mean, to be very frank with you, I feel it is partly just buzzword. At some point it is hype. But there's a little bit more to it than that, right? Flask is intentionally trying to keep things very simple. It is focusing only on the part that takes requests and generates responses. Okay, so the only sort of functionality that Flask provides is it basically says that it will implement that WSGI server interface. And what is a WSGI server interface? It basically says that it will listen on some HTTP port. It will take requests that are coming in on that port, and it will then process them using certain functions that are written inside your code. Okay, which functions are to be called inside your code? Those are determined by the roots that you specify in Flask. Okay, at its most basic, that is all that Flask does. Because even something like a model interface requires another module, something called Flask SQL Alchemy, or some other thing which can be used in order to interface with databases. Okay, if I want to have login mechanisms, then there is Flask security. If I want to have something else, there will be some other mechanism, right? But the core of Flask, all that it does is it takes requests on a particular port of a HTTP server, and based on what the path in that request was, it will call some function inside the Python code and return the response to you. Okay, so Flask is intentionally trying to sort of focus on only one job and do that job well, right? Whereas Django does a lot more. So Django actually sort of has its own inbuilt ORM, the object relational manager, right? Which means that it has the ability to interface with a fair number of different database types. it also provides you with basic scaffolding, meaning that it creates a skeleton structure for you, which makes it much easier for you to develop your app. It sort of gives you some best practices and says, okay, look, construct the app in this way. It will automatically construct the basic controllers and things for you, right? It will provide you with an admin interface at all. And essentially all that you have to do is say that you want an admin interface and you get an admin interface, right? So that is the sense in which I guess it would be called a bit more of a full stack solution, because it is providing a lot more than what Flask by itself does. But that's essentially it. If you go back and look at the core thing that Django is providing, the main functionality once again lies in the ability to handle HTTP requests. Okay.
So is there any specific reason why we preferred Flask over Django?
Simplicity, that's all, right?
Okay.
I mean, from a point of view of explaining something in a class and especially not getting lost in details, Django is a lot more complicated. I mean, in the sense that you will get a nice app up and running very quickly, but there will be so many questions about why should I do it this way? Why does this work? Why does this happen? Whereas with Flask, I can literally, point at and it's like opening the hood of the car and pointing at the engine and saying, look, this is where the spark plug is, right? I can almost like look at one particular line in Flask and say, this is the part that is going to connect you to the HTTP socket, right? And it's almost that easy. That's all. So Flask was chosen purely from the point of view of making it, minimizing the extra things that we would need to explain, because the focus of this course is not a particular technology. It's not that Django is better or Flask is better. We want to try and present certain concepts, and for that Flask allows us to do it without sort of getting too much in the way. That's all.
All right. Thank you.
So just as a follow-up to that, by the way, I mean, right, Flask is used for fairly complex apps, right? So even Swayam, the overall learning platforms and so on are built on Flask. So the point is that a person with a good degree of experience in Flask will be able to build really powerful apps using Flask. Having said that, it is not our purpose to tell you that Flask is the right way to do something. No, not at all. Far from that. We are not interested in answering that question. If you ask me which is the best framework to use, I simply don't have an answer for that. And the only real answer is, it depends on you. It depends on what you get experience with. It depends on what you are comfortable with. Different people have different programming styles and find that they are comfortable with different ways of writing code. But what we have with regard to Flask is something that is sufficiently simple that we consider that you should at least be able to do this. You should not have too much difficulty in managing this. And at the same time, it brings out all the concepts that we are interested in. Okay, that was it.
All right, thank you.
Sure. Okay. Yes, Rakesh, go ahead.
Hello, sir.
Yes.
The parser for example, can I say that it is actually HTML parser? Sorry,
the parser for what?
XML parser. Can I say that it is actually an SGML parser?
It is probably a subset of HTML. I mean, see, XML is one particular variant of HTML, right? HTML, I mean, there might be things in HTML that are not supported in XML, for example, right? So it's not the same. You do have a difference. It's sort of probably like saying that a C compiler cannot compile a C++ program. Okay. So there is a difference because there will be some syntax or some words or some things which are different between HTML and XML. HTML in some sense is a sort of superset. So possibly you might be able to say that if you have an HTML parser, it should at least be able to create something. It will be able to check the validity of an XML document. But that's all. See, a parser by itself is not sufficient, right? A parser is only sort of breaking the thing up and creating some kind of basic structure. After that comes the part that actually interprets it and says, okay, this is what it means. And is this a valid document or not? So the parser is just the first step. An XML parser will probably fail on arbitrary HTML documents, whereas an HTML parser should be able to make sense of an XML document. But that's all. Make sense meaning it will be able to parse it. It won't be able to tell you what the document is about or what to do with it.
Okay, sir, got it. And can you bit more explain the REST API part? Like I completely understand that the CRUD concept and REST concept is different, but in REST concept, so what is the special with it? Like, is there any alternative of REST? Like for MVC structure, we have alternative like model view model and other alternatives.
Yeah.
So is there any alternative of REST? Like if we do
Yeah,
not
yeah.
use
So
REST,
in
then
fact,
what?
I mean, so in Mad 2, we also cover a bit of that. Well, to some extent, nowadays, there is a sort of very popular alternative, which is GraphQL, right? And GraphQL is probably something that you will encounter. You may, and if you're reading about this area, you will find that GraphQL is the next big thing, and it is what happens. It is one step beyond REST, and it is better than REST, and so on. The point is, it's a different way of looking at the problem, right? So GraphQL is saying that REST sort of enforces a very specific way of structuring your queries, right? It says that if I want to sort of get the list of all students, I can have one query for that. If I want to get the list of courses, I can have another query for that. But what if I want to get the list of students who are registered for MAD1, whose name begins with A and who were born in January, right? How would I do something of that sort? In a REST API, I might have different API endpoints or different functions which answer each of those questions independently, right? It might be able to tell me that, okay, look, this is the list of students. These are their names. These are their date of birth. And now at the client end, you sit and figure out who are the ones who begin with A and were born in January. Okay, which means that I might have to end up transferring quite a lot of data, and at the client end, sit and figure out what the answer is. Now in GraphQL, what it says is we'll take a slightly different approach, because after all, from an SQL, the database point of view, I should have been able to run that as a single query in my database, right? To find out who are the students who are registered for this course and whose name begins with A and date of birth is in this range and so on. Which means that GraphQL allows you to sort of construct arbitrary queries and send it directly as a request. Okay. So in what way is it different from REST? Primarily because it sort of changes the kind of queries that you send. But GraphQL still follows this idea that, you have this separation client versus server, and the communication is only over the HTTP protocol. All of that it still respects. And the fact that you don't really have a state information at the client end, or rather at the server end and so on. It's only changing the way that you construct queries, right? And in that sense, yeah, it is quite different from how REST would normally do it. And that is why it is sometimes called, okay, instead of REST APIs, we nowadays use GraphQL. So yeah, that is probably the most concrete example I can give right now about what is different from REST and how it has evolved in recent years.
Okay. And sir, one more concept is there, like stateful and stateless. So how is it related to REST, or it is not related?
It is related in the sense that, see, fundamentally the HTTP protocol, the web, is assumed to be stateless. Okay, meaning that the server does not know in which state the client is. See, that was the example that I gave earlier, right? On your desktop, whatever it is that is drawing all the windows on your screen, the application that's drawing the windows on the screen, knows exactly what is shown on the screen. And if you put your mouse on a particular part of the screen, it knows that this is what is being displayed under the mouse. Okay, so the server, in other words, or the application knows exactly what is being seen by the client. But in an HTTP based system, the server cannot know whether the client is actually looking at this web page, or whether they only sent one request and now have navigated away, or have closed the page or done something else. They don't know at this point in time. In other words, if the client clicks on some particular thing, the server should be able to directly say, okay, this is what happened. Whereas in an HTTP application, what happens is when the client clicks on a particular part of the page, the client has to construct a request. That request has to be sent to the server. And that request also has to say, look, this was the page I was looking at. And on this page, I clicked this particular button. So in other words, the client has to send quite a lot of information about its current state to the server, so that the server can say, okay, fine, you clicked on this button on this page. All right, this is what the response is. Okay, so that is the sense in which HTTP is considered to be stateless. The server at any given point in time cannot know for sure what the client is doing. And unless the client passes that information saying, okay, I was on this page and I clicked on this button, then the server can say, okay, if that was what you did, then this is how I'm going to respond. That is where that state transfer is happening between the client and the server. The client has to sort of tell the server each time, this is what I did. Now the server will say, okay, fine, then this is my response. Whereas in a stateful system, I don't need to keep on transferring that information back and forth. Okay, does that make sense?
Yes, sir. Yes, sir. So REST is stateless.
See, REST is no. I mean, I wouldn't say REST is stateless. That is all that REST is saying is that if you have state, see, what does state mean? It just means some kind of memory of what happened before. So even something as simple as am I logged into the website, right, is part of the state of the system. Okay. So client-side state means that if I log into google.com, right, or gmail.com, it means that I am actually logged in. I have some kind of an authentication token that allows me to read my email. Okay. Now that information is known to me at the client, and something about that token which has been given to me is also maintained at the server side. All that REST is saying is, for every request that goes from the client to the server, that information about that state has to be passed from the client to the server. The server cannot assume that the client is in a particular, is always looking at this particular page and then is directly clicking on it. That's all that REST is saying. So REST is not saying it is stateless. REST by itself doesn't care about whether your application is stateful or stateless.
Okay, sir. Now it's clear. Now it's clear. And sir, one more like a general question.
Yeah.
That in various like I am able to do the assignments like and I'm working on the project also. That is okay, but that the concepts or the terms, those are not completely clear. So what type of things I should do? Like I should do practice, or if I should practice, then what type of things I should practice, or I have to read the documentation? Like how can I get the like fundamental like a good concept or intuition?
See, I mean, I don't have a general answer to that. The one thing I can say is this is an area, right? This whole application development area, and especially web application development, is something which is very rapidly evolving, right? Even now there are things. So like I told you, right? I mean, I've talked about REST, but already people are talking about going beyond REST and saying, okay, GraphQL is the future. Now, is it the future? Should you straight away jump to GraphQL without understanding what REST is? I don't know. I mean, I don't think that makes sense personally, but there might be people who argue that why are you even wasting time with REST? Jump straight to the new thing, right? Similarly, there might be people who are saying Flask is outdated and unnecessary. Why are you wasting time with this? And why are you doing RDBMS type things? NoSQL is the way to go. But the point is, all of these are sort of, they are different technologies. Each has its own benefits. In general, it is almost impossible for everyone and for you to know everything, all the different possibilities that exist at any given point in time. Right? So the only thing to do is whichever one that you are starting with, you make sure that you try and understand that as well as possible. And whenever you get any new concept, try and relate that to what you already know. Right? So when you see NoSQL, for example, the first thing you should try and understand is in what way is it better, or what way is it different, or what problems is it solving that could not have been solved using a regular RDBMS. Okay, that will give you a much clearer picture of what NoSQL is about. And it will also help you to sort of brush off a lot of the hype around it and say, okay, is this actually useful, or are people just sort of going on about it without having anything of substance in it, right? So that is something that you really need to be careful about, right? It is one of those things where there are so many different things happening. I mean, just given the nature of the field, right? This is something which is undergoing rapid evolution even now, which is why we end up with this thing that you sort of, the only way to sort of keep up with it is keep reading, but don't try and understand everything at one shot. You try and relate it to what you already know, and then sort of see, okay, is this useful? Should I be learning more about it, or can I just leave it aside for now and focus on what else I need? That would be my suggestion. I don't have a I mean, bottom line is there's no book or no standard place that you can go and read everything and just learn all the terms at one shot. You pretty much have to keep reading and sort of seeing where ideas come from and where they are explained in different ways.
Yes, sir. Yes, sir. I got the idea.
Sure.
Thank you, sir.
Okay, so yeah, if there aren't any further questions, right, at any point, of course, please remember, please feel free. The discourse is a good way for having somewhat asynchronous discussions, right? You can always post a question there, and even if I have not picked it up directly, others or one of the others would be able to tag me on it and make sure that we sort of get a response on that. So please feel free to use that, because I think more than even me or the other instructors pitching in, the fact that you are able to talk to each other and learn from each other, I think is one of the most important things that we expect over there and would like to see. Okay, so yeah, that's basically it from my side. If there aren't any other questions, probably I might drop off. I don't know if there is anything that others, if you wanted to continue after this, or
Yes, sir. So if it was basically more of interaction with faculty itself. So if there are no other doubts, you can drop off. No issues.
Okay, great. So thank you, everyone. And look forward to interacting with you again later. Thanks. All right.
Thank you, sir.
Okay, so I guess that would be it. I hope you got some of your doubts cleared. And if there are any other than this, you can definitely put it on discourse, and we are trying to answer each, if not all, we're trying to answer most of them. Might get delayed some of the responses, but we are trying to answer most of them at the earliest. Okay, so thank you very much for joining. I hope this session was beneficial for you all. And there's a quiz coming this weekend, so this is only our first session. We'll meet again on Friday, and then also have discussion on mock. Okay, so I guess that would be it. Thank you very much.